So you have just learned C++ and you want to develop the next Unreal Engine replacement. You have just heard about something called pointers and you want to solve every problem with those. Seems familiar? Somewhere along the line, someone has probably tried to teach you how to use pointers like a caveman. Now it's 2022 and nobody uses pointers anymore. I'm just kidding. It's 2023, but most C++ compilers does not even confidently compile anything newer than C++ 17. And actually, as you're hopefully already shouting at your screen right now, what we are going to talk about is not really that you are never going to use pointers or references, but rather about how to manage ownership and lifetime of memory. So, as you probably already have figured out or read by the video title, I'm going to talk about smart pointers. Smart pointers. I'm going to bring out 5 random pro tips about smart pointers that you hopefully have never heard about. And no, I'm not going to talk about everything you need to know about smart pointers. I'm just going to make a selection of some of the things that have surprised me that people I've met did not know about. If you have heard about them all, please write in the comments to show off what a gigachat you are. Just as a prerequisite, I'm one of those modern C++ folks. Okay, not one of those everything should be functional looking folks, but you know, modern. Modern. Yes, I know it could mean anything. But at least it does not mean C++ 98. Here's my maybe slightly controversial opinion, mainly unpopular with those born before C++ 14. Don't use new. Just don't. Or at least don't use it if you do not have a really good reason to. If you use new, you're probably going to be using delete, and if you do, you're probably just writing C in practice anyway. I will probably have to make a separate tweet about that. I get it now. What you say? Is C/C++ not one language? Please just stop being mean. This is how you allocate a block of data in memory in this day and age. Auto x equals make unique APA. There's different ways to write it, but I find this way the most elegant. And if you want to share data between different parts of the code, guess what? Use a shared pointer. More on that later. But how do you allocate an array of data on the heap? Do you do it like this? New int square brackets? Or like this? Stud make unique int square brackets? No, come on, just use a vector. Also, if you return a single instance of an object from a function, return it in a unique pointer. Then you know that no one else has a copy of it. There's always exceptions to rules, but this is the basic one. With that out of the way, let's start with my pro tips. Pro tip number 1. Don't allocate memory on the heap. A weird way to start a video about smart pointers, right? But did you know there is times where you don't need to allocate stuff on the heap at all? Like the Lord and Savior used to put it, just don't use pointers if you don't have to. Just use values. Take this small program as an example. We could choose to create an object on the heap like so, but we could just as well just create the value and send a reference to it. No problem. And you know, if the struct is this small, why are we even using pointers at all here? Pro tip number 2. Custom deleter functions. Say you need to use one of those pesky C libraries that is required from time to time. If you fall down the same rabbit hole I do regularly, this is probably the way that would rub your tummy. First of all, you could actually take a unique pointer to take a pointer to the destructor function, just like a shared pointer. But then, will your compiler really know how to optimize that away? Will it be fast? And another problem, you will need to provide the pointer every time you assign to the unique pointer. Here's how you do it for real. Create a type that has operator parentheses defined. A unique pointer can use that to destroy your object when it goes out of scope. And yes, you probably already noted that a struct with an operator parentheses is almost just a lambda. Then let's use that instead. Note that we will have to use decal type to get the type of the lambda, since the unique pointer does not accept a lambda by value here. It's somewhere there you'll realize that you have spent a day trying to optimize one single pointer that is initialized once in your program, and you would probably be as well off using a shared pointer instead. Here's how you do that. I'm sorry for making your application super slow, but you will thank me later. Pro tip number 3. Here's a short one. How do you do if your create function returns a unique pointer, like you should, but you want to convert it to a shared pointer? Do you have to do some magic casting? Static casting maybe? Or dynamic pointer cast maybe? No, actually. Since it's a very common use case, a unique pointer automatically converts to a shared pointer. Just as a side note, in this example, as you've noted, there is no real reason to actually use a shared pointer. If your code only looks like my current example, you should just use a unique pointer all the way. Always prefer unique pointer if possible. And as I mentioned earlier, there's some good reasons for when you should use a shared pointer instead. I just feel that I have to address all the performance junkies watching this video. You have probably figured out that recommending shared pointer instead of unique pointer will be a terrible overhead. But honestly, if optimization happens in the forest, does it even exist? Just confess that you have not measured your code. If your code is more readable and you have not noticed any performance issues, you don't have to change it. I mean, if you're not writing for the fun of it, that is. Pro tip number 4. Make shared. I realized that I need to make a dedicated video on how shared pointers work. Most people have some kind of understanding that a shared pointer is reference counted. But have you really thought about it? Where should the reference counter be located? You cannot store it on the pointer object, the shared pointer, since that will go out of scope. You cannot store it on the object itself, since you need to be able to create a shared pointer from a raw pointer that does not have a reference counter anywhere on its allocated memory. You need to allocate a new piece of memory that just keeps track of the reference counts. That is why the shared pointer object is actually 2 pointers. One that points to the object and one that points to the control block. That seems super slow, right? This is where make shared comes in. It allocates the control block and the objects at the same time and releases them at the same time. Also note that there is some special cases when there is a weak pointer pointing to the object and the memory cannot be released. Let's just assume for now that you do not use weak pointers at all. Pro tip number 5. Shared pointer void. Speaking of shared pointers, say your application creates some objects that is never interacted with directly. It could be that they hold some data used by another thread, or that it holds file handles that is used throughout your program, but needs to be destroyed or closed when your program exits. Also, let's pretend that there is no std_any. That will be another video. How do you manage this memory in as lazy way as possible? With shared pointer void, of course. This is one of those constructs that seems totally useless on the surface. Why would you like to store a pointer to a void? This is why. And you're not actually storing a void pointer. A shared pointer does not need to know the underlying type of the object, since it also has a pointer to the destructor function that is going to be used on the object. You just assign the object, as usual. Boom, done. That's it. Thank you for watching. Please comment if you want me to elaborate on some of the subjects. And remember, just don't have a catchphrase yet. Just take care and I will see you in the next one.